Finally, we come to the last page of our review, division. So, long division, synthetic division, finding all factors and roots of a polynomial. We start this off with an example of polynomial long division. So first off, you are asked, you're given this problem right here, and you're asked, do you have to use long division or can you use synthetic division? Well, the answer is you must use long division. And we know this because our divisor has a leading coefficient that's not 1. Whenever the leading coefficient of the divisor is not 1, or in more advanced examples, if you're dividing by, say, a quadratic like x squared plus 5, or even a quadratic trinomial, in those examples, you would have to use long division. We didn't do any examples like that. This is all we did with long division. All right, so let's do the long division. So let's remember our process. We're going to compare our leading terms at each step. We compare, and then we will multiply. We will subtract and bring down. So 2x goes into 4x cubed. How many times? Well, that would be 2x squared times. 2 times 2 is 4, x times x squared is 4x cubed. Now I need to multiply my whole divisor by that. You can write it off to the side if it helps you. If you don't feel you need to, you do not have to. 2x squared times 2x is 4x cubed. 2x squared times negative 5 is negative 10x squared. So I've multiplied, and the next step is to subtract. When I am subtracting, that means I am changing the signs down here. So I will use a pen and mark over it. Minus 4x cubed and plus 10x squared. Which gives me 0 and negative 10x squared. And I bring down the next term. Now I repeat this process over again. 2x into negative 10x squared is negative 5x. I multiply, and what do I get? Negative 5x times 2x minus 5 gives me negative 10x squared plus 25x. And I subtract. This will then give me 0, that's the idea for the leading terms, and here I get 6x, not 0, 6x. I bring down the negative 10. So 2x minus 5, 6x minus 10. How many times does 2x go into 6x? I'm going to write plus 3 up here. And 3 times 2x minus 5 is 6x minus 15. Again, remember, long division is always the same process. Compare, multiply, subtract, and bring down. Compare, multiply, subtract, and bring down. It's a cycle. Now I will subtract. So I change these signs. And it looks like my remainder is 5. So I can take that remainder and write it over my divisor. And right up here, this whole thing, which I don't have space to rewrite it, that is my quotient. That is my answer. 2x squared minus 5x plus 3 plus 5 over 2x minus 5. Now the question also asks us, after dividing, is 2x minus 5 a factor of this cubic? And how do I know? Well, the answer is no, it's not. And the reason is because if it were a factor, the remainder would be 0. Since the remainder does not equal 0, it's not a factor. Now I'm going to move on. I got 3 more problems to do here. Now note, for both of these, I see my divisor is x plus 4 or x minus 2, and I remind myself, as I asked for the first problem, whenever my divisor is just x plus or minus some number, that means that I can use synthetic division. So what I'm going to do here from the dividend, the thing I'm dividing into, I will take the coefficients only. And from my divisor, what I will take is its root, or 0. So I draw my big L-shaped thing here. I write my coefficients, 4, 9, negative 25, and 9. And the root of x plus 4, if I say x plus 4 equals 0, x equals negative 4. So that's what I'm going to use. Now remember, the process for synthetic division, I will drop the first term, then multiply. 4 times negative 4 is negative 16. And then I will add. And I will multiply and add until I am done. So I drop mama. 9 and negative 16 give negative 7. Negative 4 times negative 7, because now I'm back to multiplying, gives 28. I add these two and get 3. I multiply by negative 4 to get negative 12. When I add these two, what do I get? I get negative 3. Now let's remind ourselves, how does this translate into an answer for a division problem? I need a polynomial quotient. Well, remember, this was a cubic, so when I divide by a linear expression, I should get a quadratic. But the way most of us seem to feel comfortable, this is a remainder. Darn it, a remainder, a constant, and I'm going to count up x and x squared. And I can see that my quotient is 4x squared minus 7x plus 3, not 3x, pardon me, and of course today's the day I ran out of whiteout, plus 3 plus negative 3 over my divisor, which my divisor, remember, was x plus 4 still. So that is my quotient. Let's do one more example of just straight synthetic division. Now here I see 3x to the 4th minus 7x cubed plus 14x minus 10. So I note that there is no x squared term. So we recall when we're doing division, if there are missing terms in the dividend, or again in more advanced examples that we didn't do, this can also be even in the divisor, I need to insert a 0 placeholder. So I will have 3, negative 7, 0, 14, and negative 10. And it needs to hold the place of whatever term is missing. So here I went from x cubed to x squared was missing. If I had something where I went from x to the 4th down to x squared, x cubed would be missing. We can even have problems where you need multiple zeros. For x minus 2, x minus 2 equals 0 when x equals 2. Remember, I'm using the root of my divisor. And then I'm going to drop mama. 3 times 2 is 6. I add and get negative 1. 2 times negative 1 is negative 2. Adding gives me negative 2. 2 and negative 2 give me, 2 times negative 2 gives me negative 4. Here I get 10. And 2 times 10 is 20. So I add these and my remainder is 10. Now again, this is a remainder, a constant, an x term, x squared term, and I got one more here, so this must be an x cubed term. So I change this, I get my answer, 3x cubed minus x squared minus 2x plus 10 plus the remainder of over my divisor, 10 over x minus 2. Now, of course, division's a neat little process, and once you get the hang of it, it's kind of fun, I think. But why do we care about this? Well, again, it all goes back to the things we're concerned about with polynomials. How can I factor them more? How can I find all of the roots? So this is the quintessential question of division in terms of what we need to know with polynomials. One root of this polynomial is x equals negative 6. I want to find the factored form of p of x and all the zeros. So I'm going to set this up with some synthetic division. I've been given a root. So I can take the coefficients of p, which are 5, 42, 63, and negative 54, Now remember, what I always put out here was the root or 0. So I will just use -6. X equals -6 is going to imply that x plus 6 is a factor. But I'm using the root, so I just use -6. And then I'm going to drop mama. 5, -30, add to get 12. -6 times 12 is -72. If I add 63 and -72, I get -9. -6 times -9 is +54. So I get a remainder of 0, which is what I wanted. Remember, a remainder of 0 means that x plus 6 is a factor of this polynomial, or -6 is a root. So what do I have here? I have a remainder, a constant, an x coefficient, and an x squared coefficient. 5x squared plus 12x minus 9. You can factor this. I need factors of -45x squared that add up to 12, which is, -3x plus 15x minus 9. And you go ahead and finish this off. And I can see my factors here are x plus 3 and 5x minus 3. How does this answer our question? Well, let's recall. What I was asked for was the factored form of p of x. Well, I knew -6 was a root, which gave me the factor of x plus 6. And now I have found this quadratic, which I factored more, and I can see my other factors are x plus 3 and 5x minus 3. What zeros will I have then? Well, again, I start with the root or 0 that I already knew. If x plus 3 is a factor, then -3 is also a root. And if 5x minus 3 is a factor, again, don't be afraid to write it out. 5x minus 3 equals 0. Add 3 and divide by 5. And I get 3/5. I hope this has made sense. I hope it helps. Good luck. Do great on the test.